So I'll just brief it out. So today we'll not go in the detail, but I will give you the overview. So in that link which I have shared with you during the starting conversation, so it was mostly explained about the course which will proceed during the 75 hours of the classes. So we'll start with the introduction to design engineering and we'll talk about the energy scenario which is going on nowadays. So you might have heard about we are going for the green, carbon neutral. So every company, either private or public sector, are trying to run their own consumption loads on the solar, wind. Some of them are trying for the pump hydro storage also. So some are saying for the target for 2035, some 2050, and we are moving towards the green energy. So it's not easy to move to green energy. There are so many challenges associated with. So that also we'll discuss when we'll discuss about during the courses like reactive power compensations, the inertia requirement of the grid, then dynamic and transient conditions which will affect the addition of the you can say a less inertia system like inverter and all those things. And when we'll replacing the gas turbine and generators from the system, so what it is getting affected. So all those things we'll discuss in subsequent chapters. But in previous or particularly in coming next lecture, we'll study the what is the capacity of substation we have in India, what are the different loads dispatch centers we have. Then we will discuss about the capacity of transmission line, different voltage level which we have in our country. We will discuss about the rolling plan of India, which is issued by the CEA, Central Electricity Authority, and mostly we will visit a site which is the Ministry of Power has launched different sites in which you can see all those data, substation, transmission line, power, which is being generated from the fossil fuel or the renewable sector. So everything we'll discuss and you will be able to know that day to day, if you want to be updated that what is the scenario going on with the power sectors, you can view from there. Then we'll discuss about different power sources like fossil fuels, then renewables, the challenges, what are the transmission and distribution of electricity in India, all those voltage level which we are following. So in this transmission distribution, we'll give some introduction in this class, but further when we'll proceed, we will discuss you and we'll let you know that suppose you have to lay a transmission line and someone had given you that you have the 300 kilometers of line to be laid and you have 2 gigawatt of power to be transferred. So what question will into your mind is first is what will be the voltage level you have to consider, isn't it? So this will be decided based on the losses in your system and based on the capex you are spending for different voltage levels. So we will develop some Excel sheet during our courses in which you will be able to know that varying the loads, or you can say the generation, varying the distance of the lines, you will be able to show that which voltage level 220 kV, 132 kV, 400 kV or 765 kV, which voltage level will be suitable for selecting this type of generation load. So it will give you some loss parameters. So when we'll discuss about the loss parameter, so everything is linked here. So loss parameter, when we'll discuss, it means we'll discuss about the conductor in the system which we are using. There are several type of conductors which are, you might have heard, ACSR, AL59, STLS, high temperature, low sag conductors. Then we will discuss different losses, how to calculate the losses. So the loss calculation for different conductors are different as per the CA and IEEE codes. So we'll discuss in detail and we'll prepare an Excel sheet in which you will be able to calculate the losses at different temperatures and for different conductors. We will discuss in the first class about the codes and standards we are going to study. So here only the small hints will be given. Otherwise, whenever we will be doing the particular chapters like transformers, motors, generators, cables, earthing, lighting, lightning. So accordingly, I will update you which codes to be followed, which standards to be followed during that courses. For design engineer, it is also very important to know about the procurement processes. So like if I'll give you some example, you are buying a transformer. So we do the analysis for loss evaluation criteria. So particular transformer, if you are going to buy, and different vendors had given different losses. So how you capitalize the loss, how you instruct the procurement people that which transformer manufacturer is giving the beneficial offer for you. So first we'll discuss what are the contracts like lump sum key, EPC, what is the scope of work, and in detail we'll discuss about the tender and procurement processes. Some of you might be knowing all those things, but we'll take your views also. Then at last first day we'll discuss about the site selection criteria for both like greenfield. It means you have a fresh uh, raw field in which there is no installations are there and you are starting the project, and brownfield you are doing some expansion or extension of the project. So what are the criterias? One by one we will discuss in that class. Okay, so main class which will start from here is the plant load estimation. So how our class is divided. So if I'll say you so this is the first class, so participants will take some time to join and that. Okay, so when we'll start the class, so how the structure will be there. So in the terms of the complexity, if I say we have oil and gas sectors, we have transmission and distribution sector, we have renewable sectors. So if you see the complexity of design and engineering layouts which are being prepared is definitely it will be more in oil and gas sector, because in oil and gas sector the most of the equipment which is running is, you everyone know, it's a motor loads, and particularly the induction motor loads, and rest you can say 80% motor load and 20% it is approximately other static loads are there. If we compare the renewables, so in renewable sector, if you are going to design, so there is no motor load or very less, only for pumping water and all those things we are using in the renewable sector. Similarly, for T&D, we don't have the motor loads. So we'll start with the oil and gas, because in any projects, when we start with the one very important terms, which is called a load list. So load list, how we accumulate, sometimes it's very confusing word that uh, who is going to start the project. So electrical engineer thinks when I am going to be involved in this project, particularly when I am talking about the oil and gas. So we'll explain in that class that when the electrical engineer actually start his job in the refinery premises for the designing sector. So after getting a load list, the electrical design job getting started. So this motor class particularly will study first when we'll start. And for studying a motor, we will be needed to prepare a load schedule. We'll discuss about the power factor, load factor, efficiency concepts. So we know the power factor, if you have studied, so power factor, we know it is for individual motors also, there is a power factor. When we are discussing about the complete refinery final generation is there, or different buses are there. So we have the power factor for the system also. So there is a power factor for individual motor, there is a power factor for system. And third, you might have heard also, we have displacement power factor. So this displacement power factor is basically happening due to harmonics. So these problems are very much surfaced where there is a non-linear loads like VFD. Nowadays we are using the electrolyzer for the green hydrogen. So that is also an interesting concept, and you will be beneficial for that also, because we have designed in one of the company where they have executed the pilot project for 2.5 megawatt of hydrogen, which is being fed through the solar power. So I will explain what challenges we have faced during the installation of that electrolyzer. Like rectifier we had of 6 pulse, and it has further degraded the system power factor, and we face sometime the penalty from the grid also for taking a huge reactive power from the system. So all those concepts we will discuss in these classes. We'll discuss how to read the process flow diagram, PFD and PNID, motor data sheet. So for if someone is thinking that this is not correlatable to them, but actually knowing a plant and motors and all those things are actually the starting of the basic engineering. So in that motor class, so the motor class will be related to this one. So concept of normal running load, peak load demand, and here we will start with the equipment sizing overview. So after getting these things from the load list, will we finally be able to start the sizing of the equipments. And before sizing of equipments in detail, we'll discuss about the motor specification data sheet, how we are selecting the motor as per the voltage levels. So you will be always having a confusion that I have suppose 90 kilowatt of motor. So what voltage level I should use? Shall I use 415 volt, 3.3 kV, 6.6 kV, or what? There is some transition kilowatt is also there, suppose 160 kilowatt or some 200 kilowatt. So it's very confusing among the people that which voltage level to be chose and what are the criteria we follow for selecting this and grouping the motors in the MCC. So that we will discuss in very much detail. We'll take an example of a captive power plant of a refinery which I have worked there, and that captive power plant will list all the loads and will select the voltage levels, how they have decided based on the different parameters. Then we'll discuss all the parameters of motor, power factor, efficiency. So in efficiency also we'll discuss, we have different type of efficiency motors available in the market. So suppose uh, super efficiency, high efficiency, premium efficiency. So again, there is a case that if I am selecting a motor, so which efficiency level I have to choose. So again, we do the cost benefit analysis here, that taking a loss is better or paying a upfront price now is better. So we'll do the NPV calculation for the losses we will occur for the lifetime of the motor. And then we will able to say that, okay, this motor is suitable for efficiency 2 class or 1 class or 3 class accordingly. In detail, we'll discuss about the duty, motor duty, starting methods, load factors, motor cooling methods, mounting methods, insulation, temperature. So all these things will be, uh, you can say, changing a temperature and altitude will derate your motors. So we'll discuss what percentage actually it derates and what conditions. We'll discuss the IP and degree of rotation, direction of rotations. In detail, we'll discuss the motor protection. So somewhere we might have heard about the type 1 and type 2 protection for the motor. So basically the motor which is contactor fed and less than 55 kilowatt motor. So we use the type 2 coordination. We have phased out this type 1 coordination. We'll do the coordination and we will evaluate the size of fuse or MCCB which you are using, or MPCB you are using. We'll calculate the size of the overload relay, the selection of overload relay, and finally the selection of or sizing of the contactor which we are using, we'll discuss. So finally it will complete the protection of motor for less than 55 kilowatt. Then we'll go for ACB fed motor. Then we'll discuss about the overloading of the motors, thermal overloading, negative phase sequence. Then we'll discuss about the uh, overcurrent and earth fault protections for higher motors. And further we'll go when the motor is more than 1 megawatt. So differential protection also we use. So in detail we'll discuss all those protections also. Then we'll come to the single line diagram. And this transformer will go parallel to parallel, because when I am saying I am going to select the motor, transformer and SLD, so why it is parallel? So if I'll draw SLD, just a simple. Anyone is having any doubt can ask anytime. I'm just explaining in the flow, so you can stop and ask that these things will be covered in this chapter or not. So I'll explain upfront. So I am talking about suppose a generator is here. It is generating 11 kV. We have a generating transformer which is 11 by 33 kV. All those parameters I will discuss in detail when we'll discuss vector group, percentage impedance, and all those things concepts. Then we'll be having a 33 kV board. Then we'll be having suppose 33 by 6.6 kV. Then further we'll be having a PMCC. So this is 6.6. We have MCC, which is 415 volts, so 6.6 by 0.433 kV. All the loads which will be connected through motor loads through this MCC. Some ST motors will be there, which will be connected through 6.6 kV board. Then there will be transformers of different ratings will be there. So basically the approach will be there. We will discuss about the motor, which is the first part or the starting part of the single line diagram. Then we'll discuss about the transformers, the sizing selection of the transformer. We'll discuss about the switchboard. So the MCC or 6.6 kV switchboard. So the rating, like if I'm writing here 6.6 kV, suppose it is 1000 ampere bus bar rating, its fault level, suppose 31.5 kiloampere for 3 second frequency, then bus bar. So all those things are being written like this. Every parameter will discuss how it is being selected, how the timing is being selected. So the fault level, the coordination part, that will be discussed during this. So the flow will be like this: motor will complete, transformer sizing will complete. So finally, we will be able to do the sizing of the major equipments. Then we'll discuss the generator sizing. So up to this flow in the transformer, what we are going to cover, we'll do the distribution transformer sizing and different transformer specification data sheets. The concepts of cooling. So we have on off, ODAF, all those things we'll discuss. Overloading is very important parameters in uh, transformers. So if I am talking about the solar transmission transformer, generator transformer, so different overloading will be there. So solar transformer will be having a cyclic duty nature. It will be having a overloading for suppose 2 to 3 hours only. So we'll discuss as per IC 60076 part 5, and I will discuss with the IS 6600 also. So overloading concept will be clear to you that what overload you can do with your transformer. So different transformer which is running for different application can be overloaded differently. Tapping impedance, it's a very useful parameters for transformer. Transformer regulation, vector group in transformer. So it's very important topic. I will discuss in very easy way. You will be never able to forget this vector group. Then we'll discuss about the core winding material, all the losses. So in this losses, again, we'll discuss about the loss capitalization as per the CEA methods also. And as per your generation cost, what is there? So we'll compare with that, how this losses are being defined, like some manufacturer is not meeting the losses. So what penalty you can impose for per kilowatt loss it is giving extra to you. Then we'll discuss about the dielectric strength. So dielectric strength, we know we have defined the lightning impulse voltages for the insulations. We define the switching impulse, chopped wave frequency, power frequency, we stand for 1 minute. So what are these voltages and how we define for different voltage levels is will be discussed during the class. It's very important. Based on that, we do the insulation coordination in the system. We'll discuss the concept of fault level, bushings, the nitrogen injection fire protection system, insulating oil parameters, which is affecting based on the temperature, different transformer testing, in which the short circuit of the transformer is always being discussed during any project, that do we require a transformer which is having a short circuit tested, because it's a special type of test and it's a destructive test. So we'll discuss about the similarity criteria also as per IC 76 part 5 annexure B, and we'll discuss the different protection in the transformer, and from here it will be comparable to different transformer which is being used in the different industries. After this, we'll We'll go walk for the generators. We'll do sizing of generators. What is the concept of effective loading, overload capacity, step loading, voltage dip extra will be evaluated during the generator sizing, and generator protection which will be used, we'll discuss in detail. So everywhere in motor, generator, transformer, I have written a protection, a single line. So basically, if you see, the protection and coordination are being listed here. So the protection which is not common to everyone, like motor, transformer, and generator, will be discussed individually. The protection which is common, like for a system, we are doing the uh, primary or backup protection concept. Like backup is overcurrent and earth fault, and we are doing the coordination for overcurrent and earth fault. Then we are having a primary protection, which is also called a unit protection, like differential and distance protections. So first we'll start with the fundamentals, why it is required. So reliability, selectivity, sensitivity, everything we'll define. Based on that, we'll decide what is the difference between these two protections. In detail, I will calculate the all these instantaneous definite mean time, inverse definite mean time, overcurrent and earth fault protection. We'll do the Excel sheet coordination also. So IDMT, you might have seen we coordinate like this. So how it will be performed on Excel sheet, and we'll compare it with on ETAP also. So that will be some interesting topic for you. We'll discuss the primary and unit protections. So unit protection like differential. We'll discuss the transformer differential, generator differential, motor differential here. We'll discuss the restricted earth fault protection also. So why even having a differential protection, we are also using the restricted earth fault protection. So in this case, I will discuss you the winding. You might have seen the concept somewhere that fault which is happening at this point is a different magnitude. Fault which is happening at this point will be having a different magnitude. Fault at mid of the winding will be different magnitude. Fault near to neutral will be having a different magnitude. So for different type of grounding system in a transformer, it will be solid grounded, it will be resistance grounded. These fault current parameters will change accordingly. So we'll in discuss very detail, we'll discuss those parameters and how we do the settings for that. Then for bus bar, we'll discuss the low and high impedance protection. So it will be centralized or decentralized, how we select these systems, how the high impedance protection is selected and at which place, like for REF, we select the high impedance. For other differential protection, we use the low impedance. So why this terminology? What are the differences between this high and low impedance? Where we use the stabilizing resistance, metro cell. So all those calculations, CT parameter calculation, CT saturation, knee point voltage calculation, magnetizing current of CT calculation. So everything we'll discuss here. I will go to the P645 relay of transformer differential, and we'll discuss in detail how we do the settings for both high impedance protection and the low impedance protection. Then you will be able to calculate all those protection very easily. So before this protection I have just explained, definitely for protection we need switch gears. So in switch gears we have bus bar, we have the circuit breakers, we have the disconnector switch, we have the surge arresters, and the very important parameter is the CT and PT, which will be sensing equipment for operating the relay, and for finally the breakers. So in this section, what we will do, we will cover all three segments for low voltage, high voltage, and extra high voltage switchgears, because the concepts mainly will be same for all voltage level, The differences which will be coming in high voltage, like some phenomena, control switching devices, pre-insertion registers. Then the EHV circuit breakers you will be finding the SF6 type of breakers. So how it is different from ACV, VCV, all those things we'll discuss. We'll discuss different type of disconnector switches, which are central break. Then we have double break system, pantograph. So how the one more we might have heard, the tandem isolators. So these are selected based on the area requirement which you have. We'll discuss in detail. Surge arrestor again, it's a very complex selection phenomena is here, because every type of uh, voltage level you should know. So voltage level means like it is fast front wave. So you might have got a lightning wave which will be having 1.2 by 50 microsecond characteristic. So how it is being drawn, how the uh, you have different voltages, like chopped frequency will be having different wave shape. Then we have the switching frequency will be having different voltage wave. So for different voltage wave, we will calculate, and how the surge arrestor are being selected. You will be able to know this power frequency withstand is this voltage is not being required to be coordinated with the surge arrestor. This is only the parameter which is to be withstand by the surge arrestor. So all these phenomena we will discuss, different type of wave shape we will discuss, and where it is happening, what are the durations, and how it is being selected. So in detail from LT to, because we use the surge arrestor in motor feeders also, we use in EHV systems also. Then in breaker will be discuss the concept of arcing. What is the re-striking voltage? How the arcing are extinguished? What are the ionization, de-ionization phenomena? How the dielectric strength of the medium is getting changed when you are using different cooling mediums in the arc extinguishing chambers. So based on the recovery voltage, the rate of rise of recovery voltage, that we'll discuss in these chapters. We'll discuss the components like making, breaking, short circuit, and thermal rating. So these four things are also very important. So these are applicable in LT switchgears also, LT breaker also. Even we'll discuss for the contactor. So contactor also we discuss these parameters. And for switchgears, breakers also we discuss about these parameters. So in detail, we will discuss about the asymmetric components of the fault current, in which we have symmetrical and DC components are also there. So based on that, we derive the making current and breaking current. I will explain you on which region your circuit breaker is operating and what is that region in that chapter in detail. For instrumentation transformers, we will discuss the accuracy and protection class. So for CT, you have metering class like 0.1, 0.2, 0.2s, 0.5, 0.5s also. So what are the differences? Where you are using which type of CTs as per the accuracy you are using for the protection, you are using for the normal metering, you are using for the tariff metering. So actually, what are the differences and what are the accuracies we are measuring is very important. So we'll discuss from LT CTPT to CTPT, which are being used in EHV system in very much detail. So after this, we'll discuss power and control cables. Power and control cables, first we'll discuss the construction details. So sometimes it is always in a engineer's mind that I am not manufacturing the cable, and most of the technologies are with the manufacturers. So I will be depending on the manufacturer for the cable I am selecting, but it's wrong. Mostly 90% of the engineering will be done by the design engineer. So actually you know your requirement, you know your cost, you know your fault level in your system, you know your ampacity in the system, you know how you are going to lay this cable, you know what is the number of cables you are going to lay, you know what is the harmonics are present in your system, what manufacturer will give you. Manufacturer will give you the ampacity of the cable at different derating factors. So what will be the different derating? So cable is manufactured based on some basic assumptions. So if I say you, it is designed at 40 degrees C air temperature, it is designed at single cable is running, there is no other cables with it. It is when I'm talking about the air, cable is laid through the air. When cable is laid through the ground, some more parameter will come like 30 degree it is designed. It is designed single laying. Here it is important at what depth you are laying. Again, it is important at what voltage level you are laying. What is the voltage level of cable? What is the thermal resistivity of the cable, the earth, soil? So all these parameters will be fixed by the manufacturer and they will provide you the D rating. So if you are changing from these parameters, then the D rating will be applied and final ampacity will be calculated. So these are the design engineer's job. Manufacturer will give you the cable based on the IS which is applicable. So suppose if I am saying 7098, so they will design the cable based on this. Now it's your choice what insulation, what material of the cable you want to purchase depending upon the ampacity and the temperature rise requirements. So we'll discuss those things. We'll discuss selection, sizing, the ratings, voltage drop calculations. We'll do for AC single phase. We do for three phase. We do for DC cable voltage drop calculations. We'll prepare a cable schedule, cable tray, drum schedule, how to select the accessories like glands and lugs. So this is very small thing, but it becomes very important when you are doing some overseas project. So when you are missing or you have done a wrong engineering for selecting this gland and lugs, so you can imagine this small cost equipments can delay your big projects by sufficient time. So it's very important to take care of the small parts also like the mission kits, trefoiling, clamps. So in cable, it's not very easy to design. There are so many phenomena. Somewhere people will ask you why you are laying the single core cable, why not three core cable. Some will ask you why you are using the armor. When you are using the armor, can you connect? Will you connect at source side the armor to ground or you will connect to load side or both side? Why we are doing the trefoiling? Why not we are laying in a flat condition? So what will be the unbalance? How it will be unbalance will be taken care in the cable. So different thing. What is the sheet voltage in the HV cable? How it will being minimized? How we are doing the transposition of the cable like we are doing in a transmission lines. So many phenomena are there in the cable itself that we'll discuss in cable classes. I will give you the cable sizing calculation for each level feeders. So it will be either this voltage level, which is the incomer, or it will be a motor feeder cable, or it will be a MV or LV cable. So different type of cables and what are the criteria? Like we know for the cable, we select the short circuit criteria, we select the continuous rated current criteria, we consider the voltage drop calculation. So based on that, we'll do the cable sizing. We'll discuss the cable laying types, cable routing. So we'll discuss different codes, standards which we are following. Some people will ask you, can I use the in solar plant the DC cable to AC cable, or AC cable we can use in a DC cable? So all those things we'll discuss in complete detail in this chapter. Then it comes the illumination and lighting. So there are some confusing concepts like candela, lumen, lux. So like we are in power, we say horsepower. So similarly in lighting, we say the candela, like a power of a candle, like a power of a horse we compare. So all those concepts we'll discuss here. We'll discuss the radiation, which is the electromagnetic radiations will be there. So what will be the visible lights and the photometry, all those concepts we'll discuss. We will calculate the lighting fixture. First, we select the lighting fixture, then we'll calculate with the manual calculation. So if you are having a room size available for the indoor, so how manually we calculate the number of fixtures. Outdoor, if you have a street light or a floodlight is there, then what lux level you have to achieve and what is the polar curve. So the important concept in solar, the lighting is the polar curve. So how to read the polar curve, and based on that you select the fixture for different areas. Like for control room, it will be different. It is suppose it is recess type, batten type, LED bulb type. So we'll see the polar curve and accordingly we'll select the type of fixture. We'll calculate the number of fixture manually for both indoor and outdoor lighting. And the same thing we'll do with the help of the Dialog software. So what we'll do, we'll first case we'll prepare a room, or you can say a switchgear room. Then we'll place a chair, table, door, window, everything in there. We'll place a light fixture. We'll do the lux calculation. Then second case we'll do, we'll import the AutoCAD file of your substation layout. And on that we'll make a building, switchgear building and control room building. We'll do the lighting and we'll whatever the desired lux level which is as per IS is required or as per the specification given by the client, we will design that. The next part will be the earthing and grounding. So we'll discuss the basic concepts of earthing system. So you might have seen the TT type, TNS type, TNC, TNCS, IT. So these are basically based on the earthing provision at substation end and earthing provision at your premises end. Type of grounding, like it is ungrounded, resistance grounded, reactance grounded, solid grounded. So based on this, these notations are getting changed. And for which application, which earthing system we are using, we'll discuss in detail, and why this earthing is required and what are the type of earthing system we'll discuss in very much detail. So you'll be able to know that during the fault, these all earthing system will behave differently. And sometimes we require the resistance grounded system. So you might have studied the high impedance grounding, low impedance grounding also. So we'll discuss why it is, why we use the NGR, why use the NGT in the system, why we sometimes use the ungrounded system. So what are the benefits, what are the disadvantages of these systems, that we'll discuss in detail. And also we will see these things in case of when we'll do the fault analysis. So fault analysis will, like we do for LG, LLG fault, triple LG fault, three-phase fault. So in these cases, the behavior of the system will be different for different cases, even for different type of grounding systems are there. Then we will derive it based on the symmetrical components. So we'll derive the positive sequence component, negative sequence component, zero sequence component. We will draw the equivalent diagram for generator, for transformer, for motors. For all these sequence component we will draw, and we will be able to see what is the difference for these. So suppose in transformers, the percentage impedance is defined. So actually this percentage impedance is, you can say it is positive sequence impedance, and it is the negative sequence impedance, which is equal to the percentage G which we calculate. The manufacturer also mentioned the zero sequence impedance of the transformer. So sometimes it write it is 0.8 or 0.9 times of the percentage Z, which is the short circuit fault impedance. So how it is being calculated, we'll draw, we will calculate, we'll study the Thevenin equivalent, and we'll able to know all these parameters in detail. We will do the earthing calculation. So as per IS 3043 for the plant substation, and we'll use the IEEE 80. So in IEEE 80, when we'll go to study, so everything related to earthing. So earthing system, we know we will be able to calculate when there is a LG fault, LLG fault. So what actually the fault current will come, we will calculate. Also we'll see in a different substation the voltage level. As per voltage level, the CA has defined the short circuit to be maintained. The parameter which is to be maintained has been defined. So we'll sometimes we take that values also. And when we have the all these component resistance reactance are available, then we can easily calculate the fault current in our system. So for designing a earthing or grounding, first thing required is the earth fault, from where we calculate the area of conductor which is required. After area of conductor, we calculate the effective resistance of your grid. After effective resistance, we calculate the ground potential rise, which will happen when the fault will be there. And further, this ground potential rise will be compared with the tolerable step and touch potential of a human body. So when I am talking about the human body, so again in IEEE, it is very elaboration. They have elaborated in very much detail. They have started with the experimentation, which is started on the human being also. So they have given currents to some, started with the animals, then different like rat, pig, cow, and on human also. And the sensitivity of the ampere of the current they have decided. Based on that, they have derived empirical formulas. So they have derived the empirical formulas for 50 kg human body, for 70 kg human body. They have defined what actually the human body can tolerate when there is a lightning strike in the substation, when there is a fault in the substation. So it will show you that if human is touching the any body of the metal, so earth fault current will flow like in this way. When it is there in a substation and not touching anything, and if there is a fault there, so there will be a voltage difference will be developed between two legs. So we define it touch potential, we define it the step potential. So this is first we'll calculate the tolerable capacity of a human being, and then we'll design the earth mesh of our substation, and we calculate the actual step and touch potential of this grid, and it will be compared with the human being tolerable limit. And then we say, okay, my design is correct and acceptable. So whatever the parameters will come, so in great detail, we'll be able to know. We'll also able to know, suppose I have my substation here at this premises. After 10 or 50 kilometers, there is a substation in which I am connecting. So when there is a fault happening in my system, my substation here, so what will be the contribution by my substation equipments, generating equipments, and what will be the contribution of the remote substation in this fault? So all those split factor, then decrement factors, which are being used for designing in the substation, we'll discuss in detail. So you might be thinking up to here that now we are reaching to substation design. So in substation, if I'll talk about the cable sizing calculation, transformer calculation, lighting calculation, earthing calculation, then lightning calculation, everything which we are studying for different plants will also be valid for substation design also. So one example like earthing IEEE 80 will do properly for the substation. We'll do the lightning assessment, and in detail we'll see the IEC 62305, and one famous book you might be knowing, the Den book, which is a German book which is pioneer in this lightning equipment manufacturing. So there we will be able to first assess. So first we do the assessment that really the lightning protection is required or not. What is the LPL 1, 2, 3, 4 according to the system, and we check, okay, if it is required, then with which method we should protect, either with rolling sphere, angle criterion, or in substation. Now we use the most famous is the Rejvig method. So Rejvig method is having a mast theory. So for lighting, we use the lightning mast. So through mast also we do the protection in substation along with the shield wire which is running through the tower peak. So these all things are related to substation. So whatever remaining out of these, like battery charger sizing calculations, UPS sizing calculation, then we have short circuit force calculation, sag and tension calculation for structure design. So all these parameters we'll discuss in detail in substation design engineering. Like I said, in lightning also we'll study the SPD devices type 1, 2, 3, which we are using. So based on the uh, zones, so we'll discuss the zones also, like 0, 1, 2 zones are defined, and based on the SPD are defined type 1, 2, 3. So that we'll discuss there. Then we have the, if we are having a oil and gas environment, and nowadays you can work in a electrolyzer, so hydrogen for the green energy. So again, the zone and division will be very useful for you. Different equipments which are being used for different zones. We will discuss. We will discuss the IES codes, IEC codes, and we'll discuss the oil industry code which they are using, OISD. So how the zones are being defined. Suppose they have the tank of kerosene or diesel, they have the storage of the gas, natural gas, what distance it is to be maintained to come from zone 0 to zone 1, zone 2, likewise. Different equipments, you might have heard about EXD, EXI, EXE, EXP, EXO. So we'll discuss all those type of equipments which are designed for the protection in hazardous areas. Then we have the temperature class and gas groups. And finally, we'll study the nameplates. So this temperature class is very important in motors also. We will discuss about the insulation class also. So you sometimes you might have heard the motor I am taking with the insulation of class F, but temperature will be class B. So how these things will be selected, that we'll also discuss in our classes. Then we'll come to the system study. So theoretically, if I'll say, everything will be covered before, only the thing which will do the practice in ETAP. So we'll start with the load flow studies. So in load flow studies, we'll discuss the voltage at different nodes. So we'll prepare a complete SLD of any either oil and gas system or renewable system. We'll check the power factor. We'll check the voltage at different voltage levels. What is the voltage drop it is happening? What is the reactive power requirements, or it is consuming, or it is supplying. Then we'll discuss the short circuit analysis. We'll do the fault calculation. You know the generator is definitely the source which is supplying the fault, but you might have heard also that during fault the motors also supply the fault contribution. So it is like equal to the starting current of the motor, the amplitude will be that much. So when the fault is happens for starting 2-3 cycles, like for 40 to 60 milliseconds, the residual flux which is there in the motor will contribute to the fault analysis. So in ETAP also we'll see how much the contribution we are getting from the different motors also. We'll do the motor starting studies. We'll do the static analysis in which only starting current will be taken. We'll do the dynamic analysis in which motor will be completely modeled, like it is connected with the pump, or what is the starting time of the motors, and the motor characteristic we will model, and we'll see what it is affecting the voltage of the bus, and other motors are also running. So we'll do the group starting of the motors also, and we'll see the voltage dip and the contingency analysis in that case. We'll do the harmonic study with IEEE 519 standards. We will see what are the order of harmonics are there when we'll use the different pulse of rectifier equipments. After getting we'll also see how smooth the sine wave is there when we are going for 12 pulse or 24 pulse of rectifiers. Then we'll use the filters. So that filters will be uh, capacitor banks, and filters will be used which will nullify the harmonics. So capacitor banks will be taken care your reactive power requirements, and your filters will take care about the harmonics which are there in the system. So sometimes we use the active filters also, passive filters also. So that concept we'll discuss in detail. We'll discuss about the harmonics. So harmonics are also, if you broadly bifurcate, so we say even order and odd order harmonics. Further, when you bifurcate it, you say we have the third order or triple N harmonics are there. In detail also, when you go, when there is a fault in the system, then also we say we have positive sequence harmonic, we have the negative sequence harmonic, we have the zero sequence harmonics also. So what order of harmonics will be positive sequence, we'll see. What order of harmonics is negative sequence, what order of harmonics is the zero sequence, that we'll see in the detail in harmonic classes. And actually what it is affecting, how it is affecting the core of the transformer, how it is affecting the winding of the transformer, how this zero sequence harmonic is affecting the neutral of the transformer. So somewhere we will see the neutral is being oversized, 3 times of the phase rating size also sometimes. So why it is, why, what harmonics is affecting it, we will discuss in detail. Then we'll do the relay coordination study. So in relay coordination, we'll prepare a single line diagram and go from motor level to generator level. We'll do the coordination. We'll prepare a curve and we'll see how the time gradation and current gradation we are using for coordinating the different relays. And finally, we will study the renewable energy sources. So we'll start with the solar generation. We'll see the PVSys report, the losses of different portions of solar plants, starting from the module losses to inverter, cable, transformer losses. Then we'll discuss in detail type of modules. Nowadays, we are using monocrystalline, polycrystalline, flexible, also thin film. We are just started, but there are some shortcomings. We have different connectors, MC4 connectors, string combiner box selection. So how the series parallel connections are being done to maintain the voltage rating, standard voltage rating of the module and the inverters. Then we'll see the connection between module to module we do. So it's like a battery. We join in series and we join in a parallel connections. So what are the advantage and disadvantage we are facing in series and parallel combinations? So like, voltage is getting added up in series and current is getting added up in parallel. So all those things we'll study there, and how we'll reach the 1500 volt and the ampacity. We'll discuss about the MPPT of the module, the open circuit and short circuit, open circuit voltage and short circuit current of the module. So all those phenomena we'll discuss. We'll select the size of the fuse, cable selection. We'll select the combiner box, number of inputs required, then inverter, sizing of cable, and further the inverter duty transformer we'll discuss. We'll discuss difference between the string and central inverters also, where we are using and how it is giving the advantage in a different size of the plots we are getting in the solar parks or any other places. So mostly these all will be covered, and all I usually try to cover in 70 hours, but depending upon the batch pace and all those things, it sometimes go to 75 hours also and 80 hours also. So why I giving a 1 day gap here is because when I'll explaining something, you will be required to go in deep or at least revise the class, so that you will get a time and you will revise, and further we'll discuss and start the next topic. So it is very important to cover the 3 days class in a week, and you have to be the concept, your concept should be clear in this week only. Otherwise, when you will carry over to next week, then it will be very difficult for you to comprehend the further classes. So definitely the classes are not correlatable, like lighting is not related with the cable, but when it will be left, definitely you are getting the downloaded classes. So you can check, but I'll prefer you, if you are not able to revise, just tell me. I will take 1 day off also, and you maintain the pace as per the class. So it will be interesting, and we always discuss the class in a discussion manner. So I will usually ask you, you know this, or up to what level you know this. Then based on that, the pace of the class will go. So you might be having an idea about these things, but not in a detail. Some of you will be having no idea about these things. So accordingly, I move the classes so that all will be beneficial. So from initial level to the extreme level, we will go. and we'll go by discussion and understanding only. So this page also you might be having. So this is the modality I usually keep. So starting I take only 5,000 because you will be able to know how the class is getting proceeded. You will be able to understand or not, or you don't like or not like likewise. So it is my view. And if you want, you can give in a three equated amount also.